Okay, this is homework quiz 13. I'm just going to go through the answers and you can get your quiz out if you had trouble with these and just go through to make sure that you know how to do these calculations. The question is, in the following single displacement reaction, a student is given 225 grams of iron and 225 grams of sodium bromide. You're already given the balanced equation, so you don't have to balance it. The first question is, what do the coefficients 2, 6, 2, and 6 in the following equation represent? And the answer to that is the number of molecules that react and are produced, or the number of moles. For calculations, we use the moles, so we call it the molar ratio. So that would be, either one of those answers would have been correct for that question. The second question is, calculate the molar masses of iron, sodium bromide, and FeBr3. Molar mass is also known as the formula weight. You simply go to your periodic chart, you look at the weights, and the molar mass would be in grams per mole. Okay, so in the first one we have iron. So you go to your periodic table of the elements and you look up iron, and the weight of iron is 55.85. Okay, and in the molar mass, that means there are that many grams per mole of iron. For sodium bromide, we have to look up the weight of sodium, which is 22.99, and the weight of bromine, which is 79.9. Just add them together, you have 9. Carry 1 is 12, carry 1 is 10. Put your decimal in there. So the molar mass of sodium bromide is 102 grams per mole. And then the other one is iron bromide. It's actually iron 3 bromide. So the weight of iron, as we already know, is 55.85, and the weight of bromine is 79.90. And we have to multiply that by 3 because we actually have 3 bromines. So when we do that, we get 55.85 plus 79.9 times 3 is 239.7. And then you just add those two together. And so the weight of iron 3 bromide is 295.55 grams per mole. Okay, so those are the molar masses for iron, sodium bromide, and iron 3 bromide. Question number 4, determine the number of moles each of iron and sodium bromide if you have 225 grams of each of them. So what that's saying is we have 225 grams of iron, and we have 225 grams of bromine. Okay, sometimes when people get this question, they think that they're supposed to start with the molar mass. The molar mass in this example is only used as the conversion factor. In other words, if you have 55 grams of iron, you've got approximately 1 mole of iron. If you have 225 grams of iron, that's about 4 times the 55, right? So you're going to have about 4 moles. So you can kind of think that through before you even start. So don't start with your molar mass. Start with what they're giving you and they want you to find from that. So you start with your 225 grams. We'll do the iron first. And then you use the molar mass of the iron to figure out how many moles of that you have. Draw your line. Your grams per mole is your conversion factor. You have grams on top here, so you're going to have to put grams on the bottom here. 55.85 grams of iron is 1 mole of iron. Okay, now your grams are going to cancel, and you're going to end up with moles of iron. And when you plug those numbers in, you get 4.029 moles of iron. This is 4 significant figures, and this is 4 significant figures, so you can carry that out to 4 significant figures there. You do the same thing for the sodium bromide. You have 225 grams. You use the molar mass as your conversion factor. It takes 102 grams of sodium bromide to make 1 mole. You have 225 grams, so that's going to be about 2. When you get your answer, go back and make sure that it makes sense. So if we take 225 and divide it by 102.89, the grams cancel, and our answer ends up being in moles. And I got for that 2.187 moles of sodium bromide. Okay, and that makes sense. If it takes 100 grams to make 1 mole, then 200 grams is going to be about 2 moles. So that's both of those answers make total sense there. So that's how you do number 4.